Hello, my name is Joshua Hom, and I am enrolled in National University Virtual High School's AP Statistics A, and this is my project. My research question asks, how does age affect how much music a person in school listens to daily? So regarding why I chose this question, well, I decided to carry out this project because I have always pondered everyone else's music habits. I first started to listen to music when I was in 3rd grade, but it was only a very small amount. As I grew older, the amount of music I listened to grew, and now a very large portion of my day consists of me listening to music. I want to know if the same story applies to all other people, and if so, what are the trends and patterns? In me carrying out this question, I would also, hopefully, like to have insight on the amount of music I will listen to in my future. Music is very important to many people, including me, and I would like to know how much of a role it plays in a person's lifetime. So moving on to the demographic, the question isn't meant to target the general population. Instead, it will target grade school students, middle school students, high school students, and college students. Regarding the grade school students, in order to reduce the bias in this project, I managed to gather research at 2 elementary schools, and these 2 elementary schools, with the permission of the school of course, include Harold L. Woods Elementary and Tarpey Elementary. And the same follows for the middle schools that were involved in the project, and this is all to reduce bias of course. And the 2 schools are Alta Sierra Middle School and Granite Ridge Middle School. And likewise, the same with high schools, and the 2 high schools are Buchanan High School and Clovis High School. So a huge thanks to Clovis Unified School District, because it was a very huge, long process for me to be able to do research at those schools, but with permission I was able to complete this project and get it all done. Now regarding the colleges that I visited, I also had to research at colleges, and with the permission of these 2 colleges, I was able to gather the data that I needed. And the 2 colleges are Fresno State University and Clovis Community College. So moving on to how the data was collected. So I used a survey at all of the different schools to collect the data, and on the survey, it had these 3 questions that asked the age of the participant, how many hours a day does the participant listen to music, and lastly, what genre of music does the participant listen to? You know, whether it's pop, rock, R&B, jazz, country, or classical. And this is restricted to these genres only. And continuing on how the data was collected. So in order to reduce bias, I collected my data by performing cluster sampling with all of the students. I categorized the students by age in this manner. I had a 7 to 9-year-old group, a 10 to 12-year-old group, a 13 to 15-year-old group, a 16 to 18-year-old group, and a 19 to 21-year-old group. Now, going into defining cluster sampling, which is the method I used, cluster sampling is defined as a type of sampling method, and with cluster sampling, the researcher divides the population into separate groups called clusters. Then a simple random sample of clusters is selected from the population. The researcher conducts his, or in this case my, analysis on data from the sampled clusters. And in our case, our cluster, in parentheses, would be the age groups. So continuing on how the data was collected, this is an explanation of the process that I decided to go with. So I gathered the survey information from 20 people in each age group to ultimately have a sample size of 100 people. From the grade schools, I gathered information from 20 students per elementary school for both the age 7 through 9 cluster and 10 through 12 cluster. From the middle schools, I gathered information from 10 students per middle school for the 13 through 15 cluster. From the high schools, I gathered information from 10 students per high school for the 16 through 18 cluster. From the colleges, I gathered information from 10 students per college for the 19 through 21 cluster. And I used a randomized tool with Microsoft Excel to randomly choose students from all of the school's roster, and I used a Microsoft Excel tool in order to avoid selection bias on my end. So if this was confusing, worry not. The next slide is a visual illustrating what exactly I did. So as you can see, with Harold L. Woods Elementary, there were 20 kids in total, and that accounted for the 7 through 9 cluster and the 10 through 12 cluster. And the same story follows for Tarpey Elementary. There were 20 kids for the 7 through 9 cluster and the 10 through 12 cluster. Up in the top, we see that for Alta Sierra Middle School, we had 10 kids dedicated to the 13 through 15 cluster, and likewise for the accompanying middle school, Granite Ridge Middle School, we also had 10 kids for the 13 through 15 cluster. Regarding the 2 high schools, the same story. For Buchanan High School, this was for the 16 through 18 cluster, we had 10 kids. For the Clovis High School, also for the 16 through 18 cluster, we also had 10 kids. And regarding the colleges, for Clovis Community College, this was for the 19 through 21 cluster, I had 10 kids. And for Fresno State, also for the 19 through 21 cluster, I had 10 kids. So this is a visual illustrating exactly how I went about the process of collecting data. Now, finally moving on to the data. So this is a bar graph, or a circle graph, or also known as a pie graph, revealing the data for the genre of music that people prefer. So we have a little key here. Orange, right, is R&B. So 43% of the people preferred R&B music. 27% of the people preferred pop music. 5% of our sample preferred classical music. 10% of our sample preferred country music. 9% of our sample preferred jazz music, and 6% of our sample preferred rock music. So, going back. So, continuing on why I included this information on the survey, or asked this question on the survey. So, the information regarding the genre of music serves as information for possibly a future project that will go more in depth about how preference for a specific genre of music can influence how much music a person listens to. But that will be, of course, for another project down the line. This could be a possible extension for my current research project. So moving on to, or continuing on the rest of our data. So regarding the grade schools, now of course this is cumulative data from all the grade schools. For the age 7 through 9 cluster, for the hours listened to music, this bracket shows all the number of hours that kids listen to and that they charted down. So when we find the mean of this data, it comes out to be about 1.6316, and the median is 2. So ultimately, kids in the age 7 through 9 cluster listened to, on average, about 1.6316 hours of music. Now it's the same story for our 10 through 12 cluster, except this time, on average, kids listen to about 2.15 hours of music. Now moving on, regarding the middle schools, now this is also cumulative for all the middle schools. For the 13 through 15 cluster, the kids listen to an average of about 2.95 hours of music. Moving on to the high schools, also cumulative. For the 16 through 18 cluster, kids listen to an average of about 4.35 hours of music. And for the colleges cluster, for the age 19 through 21 cluster, kids listen to about 4.55 hours of music on average. So, I'm going to go more in depth about what this data means. So in order to observe the general trend through the cluster groups, we will observe a line graph with a linear regression approach. And all the linear regression approach says is that all it does is it finds the line of best fit with the data that we plot. And it finds the sum of the residuals to ultimately become 0, and the residual is how far apart a dot is from the line of best fit. So we will use the mean rather than the median, because in every cluster, I calculated no outliers to be found. And to the right are the calculations proving that there were no outliers. The equation to find outliers there are actually two. So you just find what your lower boundary is, what your upper boundary is, and you see if it exceeds the upper boundary or if it goes below the lower boundary. So we have all the data, and the equation for the lower boundary is first quartile minus 1.5 times the RQR, and for the upper boundary it's the third quartile plus 1.5 times the IQR. So for the H739 cluster, the lower boundary came out to be negative 0.5, and the upper boundary came out to be 3.5. For the 10 to 12 cluster, the lower boundary came out to be negative 0.75, the upper boundary came out to be 5.25. The 13 through 15 cluster, the lower boundary came out to be negative 1, and the upper boundary came out to be 7. For the 16 through 18 cluster, the lower boundary came out to be 1.25, and the upper boundary came out to be 7.25. And for the 19 through 21 cluster, the lower boundary came out to be 2.5, and the upper boundary came out to be 6.5. So what does this all mean? Well, now that we know what our lower boundaries and upper boundaries are, we can look back to our previous data, and after checking on it myself, there were no numbers for each cluster group that exceeded any of the boundaries. So therefore, we are able to use the mean. So this is a graph of the data. On the y-axis, we have the average number of hours participants listen to daily. And for our x-axis, we have the age group of the participants. And now notice that this is 1, 2, 3, 4, 5, and not 7 through 9, 10 through 12, 14 through 16, and so on. And that's because we're dealing with age groups here. So I assigned each number to a specific age cluster. So 1, of course, would be 7 through 9, 2 would be 10 through 12, 3 would be 13 through 15, 4 would be 16 through 18, and 5 would be 17 through 19. So we have 5 points on our graph, and the orange line would be the line of best fit. So our R squared, when calculating it, would come out to be 0.9579, and our R value, our correlation coefficient, would come out to be 0.9787. And our equation for the line of best fit comes out to be 0.71528 plus 0.80368 times x is equal to y, and y would be our average number of hours of music listened, and x is our age group. So, continuing our graph for the data, to the right is a residual plot of the data. And from the residual plot, we can see that there are no visible patterns and that the scatter is random. Therefore, we can conclude that the data is good. So in conclusion, from the data, we are able to conclude that there is a strong positive correlation between age and the number of hours of music listened to by students in school. We can infer through the equation found from the data that if we were to estimate how much music an 11-and-a-half-year-old kid listened to, it would come out to be 0.71528 plus 0.80368 times 2, which is the calculation, which comes out to be 2.326 hours of music. So generally, as age goes up, it goes that the amount of music listened to also goes up. So what I got out of this project, the project was ultimately a huge struggle. It was very complicated, and it was a very long process. However, it reaped its efforts. And through this project, I found a newfound respect for statisticians, and the field of statistics. And in the end, it actually proved to be very fun working on everything. Thank you.